Hello and welcome back to the Cyber Hero. So, today we are going to discuss here. I will try to explain you how two parties securely exchange cryptographic keys. Even over insecure networks, key exchange is the foundation of secure communication. So, some contents here. First, we will go through introduction part, then goals and types, then some key exchange algorithms, and last we will summarize this video. So without wasting any time, let's move towards the content. Moving towards the introduction is key exchange algorithms allows two parties, like a client and a server, to establish a shared secret key for encryption. Without sending the key directly, which is needed, if we transfer the key openly, attackers can steal it, so we use mathematical techniques to derive the shared secret key. Famous example is here. We both end up with the same key, but now on site. So this was a little bit of introduction. I hope introduction part is clear. Now, main goals of key exchange. A secure key exchange must provide confidentiality, integrity, authentication, forward secrecy. In simple words, and confidentiality refers here, attackers should not obtain the key. Integrity refers here, no tampering of file, exchanged values. Authentication. Both parties must be the who they claim to be. Forward secrecy. If keys leak in the future, old session keys remain safe. These are the main goals of key exchange. Now, types of key exchange mechanism. Symmetric key exchange. First type, symmetric key exchange. Use a shared secret key and simple. There are three methods: manual key sharing, pre-shared key (PSK), key distribution centers (KDC). These are used in Kerberos, some Wi-Fi modes like WPA, PSK. The limitation is hard to manage on large network. Simple. Another one is asymmetric key exchange. In simple words, it uses public-private key pair for safe exchange. Just like asymmetric encryption. Same here, two pairs are used here. A pair is used here, key pairs, public and private. For an example, these algorithms, Diffie, Hellman, DH, ECDH, RSA key exchange. Most secure systems today rely on these. Then we will go through the first DHA, Diffie, Hellman key exchange. How you pronounce it, up to you. What it does, it enables two parties to generate a shared secret key over an insecure channel. How it works? Both first setup. Both agrees on public values like prime number P or base G something. Then each selects a private secret number. For an example, Elias selects A, Bob selects B. Each computes a public value A, D, A mod P, so on. It's mathematics. They exchange A and B openly. Both compute the same shared secret aliases, and this is a mathematics formula. So if you want in some example video, practical demo video on this DH Hellman exchange, please let me know in comment sections. Now, another one is ECDH, an overview of an ECDH. Some features: it has strong security, smaller keys, faster computation, lower bandwidth usage. That's why modern TLS and mobile DCH use ECDH instead of classic DH. RSA algorithm overview through it, how it works. Sender encrypts a random session with the receiver, public RSA key, receiver, so as well. Main thing is it was used in historically SSL TSL, but declined due to the main reasons: lack of forward secrecy, heavier computation, susceptible to certain attackers. Now, perfect forward secrecy. I told you if you want any dedicated videos on these algorithms for separate video, I will go through them with the practical examples how they working. Now, but let me know in comment sections. You can join on Telegram channel. I have provided link in the description. You can guys through that and contact with me. Perfect forward secrecy PFS. What it means, even the server's private key is stolen later, past encrypted session cannot be decrypted. It can be achieved using a DHE or ECDH. Then key exchange in real world. For an protocol, TLS, SSL, key exchange is used ECDH, DHE, nodes used in HTTPS. Port number 443, secure communication website. SSH, DH, ECDH, secure login and remote control. Foreign protocol, IP, SCC, key exchange used DH for VPN tunnels. Protocol like Signal app, ECDH something, end-to-end messaging. For Bluetooth, ECDH, wireless peering. When we tell you what is the key exchange used in Signal app, you can answer now X3DH, end-to-end messaging. For Bluetooth, it is ECDH, wireless peering. What are the attacks that can perform on key exchange? First, man in the middle attack. Attackers encrypted key negotiation prevented by authentication certification PKI. Weak parameter attacks. Use small primers or used key makes DH weak. Repeal attacks. Old values reused to trick system. Let me summarize this video. Key exchange lets two parties create a secure shared key even over unsafe networks. Hellman ECDH are modern standards. Perfect forward secrecy protects past scenarios even if keys later. Key exchange must be authenticated to prevent MTM attacks, man in the middle attacks. If you learned something new today, please hit that subscribe button and let me know in comment sections. Do you have any confusions or you want any separate video on any algorithm? Thank you. Bye bye. Take care. See you in next video.